Hey fam, it's your boy, Mr. Wishart. Like and subscribe, merch drop on Thursdays, etc. Okay, so we did this in class. We're not going to worry about the warm up. So we're talking about what we need to do translations today. Translations, reflections, and quotations is kind of the idea. What do we need, and how do we describe them, and how do they make figures that are the same? So for translations, right, a couple things you need. You need a direction, whether it's, left, right, up, or down. Okay. Left and right. And then up or down. Okay. You also need a distance, like basically how far you're moving on the graph, right? Like if you were telling somebody to go 8 blocks to 7-Eleven, right? You would need to tell them, north, east, south, or west. Otherwise, they wouldn't be able to get there. So you need both a direction and a distance. Also, you need to make sure that there is no rotation and no reflection. So no turning and no flipping. Okay. Now the idea here, sorry. The idea here is that you're going to kind of come up with your own translation. You can come up with your own and then see how I do it. Pause it if you want to. But the idea is you gotta tell which direction it's moving. You gotta say how far. So for this, I'm gonna say that it's gonna go left and then down. I'm gonna say it's gonna go left 6 units and then down 4 units. Okay. So each point, I'm just gonna count it out. 6 left and 4 down. I could use tracing paper for this if I wanted to, but I find that just counting it out actually works better for me than tracing paper. So if I start here, I would go left 1, 2, 3, 4, 5, 6, and then down 1, 2, 3, 4. That's my A prime, right? That's my prime notation indicating that this is the image, and this is the pre-image, this is the original, and then this will be the new one. B, same thing, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Mr. Wishart, could you start with B or C instead of A? Yeah, you could, it doesn't matter. 1, 2, 3, 4, 5, 6, and then down 1, 2, 3, 4 for C prime. Make sure my edges are straight. Use my handy dandy protractor here to generate my straight lines, my straight edges. And there you go, right? So we have this translation that happened right here. Moving on for reflections. So the biggest thing you need here is the line of reflection. Basically the line through which, or about which, or over which your shape is going to reflect. Okay. Now in 8th grade, it's typically the x-axis, the y-axis. Every once in a while, you'll see diagonal lines prop up, but generally we're tested on x-axis and y-axis rather than diagonal lines. You'll see that in high school more. So I've got my x-axis here. It's kind of hard to see because that's real small. I got my x-axis horizontally, my y-axis vertically. I'll do one using tracing paper, and then I'll do one kind of with the non-tracing paper technique. So the idea with tracing paper, you're going to put it over it, trace your shape, and let's say I want to reflect over the x-axis. Again, this is the x-axis right here, this horizontal one. I'm going to kind of just give myself a line, and I'll give myself a little cross so it's easier to line up. And then I literally will just reflect or flip the paper, right? And then I will line up my line and cross on the other side. And since it's actually facing down, I have pencil lead on the front of the page, and it is actually putting kind of a ghost image on here as we do it. Right? You can see it's kind of very faint there. If we zoom in, hopefully we can see that. I'll use my straight edge again to clear that up a little bit. So this is the reflection over the x-axis here. Okay, last thing, I want to make sure that I am labeling my points. A is right here, so A prime is on the same side as, same distance from the line of reflection on the other side. B prime is right here, and then C prime is the same as C. Now, if I do a reflection over the y-axis, I'm gonna highlight it, I guess. Yeah. So I'm just gonna label here. So this was over So reflect over the x-axis, and then this will be a reflection over the y-axis. Now the idea here is if you don't have tracing paper, right, you can, you just kind of look at your line of reflection here and then you count how far away each point is away from that line of reflection, and then you go the same distance on the other side, right? So A is 1 away, so then A prime, the new one, is going to be 1 away on the other side. C is 2 away, so it's going to be 2 away on the other side, and then B is 1, 2, 3 away, kind of right in the middle right there. And then I will use my straight edge to complete my shape, to make sure it is congruent, to make sure it is a rigid transformation. So it has, matching sides or corresponding sides of the same length, and then corresponding angles by the same measurement. So yeah, this is a reflection over the x-axis here. This is a reflection over the y-axis here. Okay. Now, rotations is when it gets a little hinky, I suppose. So you need 3 things for rotation. I'm going to kind of write small because I'm going to fill up a lot of this space here. You need a direction, kind of similar to when you have a translation. However, this one is going to be clockwise or counterclockwise, right? You also need a distance or a degree of rotation. These are generally 90, 180, and 270. Okay, and then you'll also need a center of rotation, basically the point around which your shape rotates. If you're looking at a wheel, the center of rotation is the axle around which the tire rotates of a car. If you're looking at a clock, it's the very center of the clock around which the hands move around. Okay, so those are the 3 things you need. Now, I'm probably going to get a little bit colorful here. If you don't have tracing paper, I'm actually going to get a piece for this. Let's do tracing paper for the first one. The idea here is you're going to put your shape on here, put up a little bit, put your shape here, and your center of rotation. If it doesn't tell you what it is, it's going to be the origin. Typically, a lot of it in 8th grade is around the origin, 0, 0, so the center. Now, what you need here is you need it also on the back of the page so that when you trace, it actually lays down on the paper to leave that kind of ghost image. Ooh, spooky. Okay, now, if I do a clockwise rotation, right, what's going to happen is, whatever rotation you're doing, right, you kind of lay it over, make sure your cross is in the center, put your pencil at your center of rotation, and then you would rotate it. If it was a 90-degree counterclockwise, it would be like this. You would trace your shape right there, and it would be done. If it was a 180, you would, start here. It would be a 90, and then a 180. Sorry, I'm not lining up exactly. It's like right there. And then if it was a 270, you would go 1 more. Okay, so those are kind of the 3 degrees, right? That's counterclockwise. If it's clockwise, it just goes the opposite direction. So that would be a 90 clockwise. That would be 180 clockwise, although the direction doesn't really matter. When you're doing 180, it's going to end up in the same spot, whether you go clockwise or counterclockwise. And then that would be a 270 clockwise. Okay. If you don't have tracing paper, though, you have to follow the rules. Okay. Now, the rules are a little bit complicated. We're going to do typically these only work for counterclockwise rotations, but it's pretty easy to figure out the rule for clockwise once you understand counterclockwise. So we talk about it in terms of 90, 180, and 270 again. Okay. Now, for a 90-degree rule, what's going to happen is you're going to take your x and y from each point here, you're going to flip them, and you're going to change the sign of the first one. And that's kind of how we indicate that. Now, this whole thing relates to the signs of the x and y in each quadrant right here. So quadrant 1 is positive, positive. Quadrant 2 is negative, positive. Quadrant 3 is negative, negative. And then quadrant 4 is positive and negative. I would encourage you to write this as a guide whenever you have any kind of shapes like this, or any kind of transformations you're doing. Okay, now a 180 is negative x, negative y. Basically, you don't flip your x and y, you just change the sign of them. This doesn't mean make it negative. This means change the sign from positive to negative or negative to positive. You can also understand where you're going, whether it's quadrant 2, 3, or 4, and then matching your points to the sign indicators, right? First one negative, second one positive for quadrant 2, etc. And a 180 is you flip them, so it'll be y and then a negative x. Okay, so you change the sign of the second one. Okay, now I'm going to focus on B as our kind of experiment here. B is at 3, 4. Okay, so if I follow the rule and I'm going to do clockwise rotations, I'm going to do a 90. Sorry, I'm going to do counterclockwise rotations. I'm going to do a 90 clockwise, a 180, and then a 270. Okay, so if I apply the rule to just point B right here, right, what's going to happen is I'm going to flip-flop them. So it's going to be 4 and 3, and I'm going to make the first one negative. So it's going to be negative 4, 3, which actually matches to that negative positive. I can know it's going to go in quadrant 2 because it's only 90. So I would go left 4 and up 3. So that's our B prime. Now, I'm actually going to do this on our tracing paper and see if I am correct. Match that as B. Now I do a 90-degree rotation. Oh my gosh, look at that. It lines up pretty perfectly, okay? I could compare A and C as well, and the same exact thing would happen. I would flip the X and Y, and that first one would be negative. So yeah, this becomes negative 4, 3. And then let's do this, and this, and this, to make sure got that down, right? And then, this would be C prime, and that would be A prime, right? This is 1, 2, this is negative 2, 1, this is 2, 0, this is 0, negative 2 for C prime, right? But again, we're just looking at B for, to test the rule right here, okay? Now, for 180, I know it's going to go 2 quadrants, right? So it's going to be in quadrant 3. So I do a 90-degree, and then another 90 gives me 180. You know what? I'm actually going to do the rule first. Sorry about that. So for a 180, I know that all that's going to happen is I'm going to change the sign. So these are positives, they become negative. So it's negative 3, negative 4. I go left 3 and down 1, 2, 3, 4. Okay. So let's double check that the rule actually works. Okay. So I do this, and I do another 90 to 180. Oh, God. Oh, look at that. It's perfect. It lines up exactly where it needs to be. Okay, then I'm going to this here, and I have my ghost image. Ooh, spooky. And I already have kind of a cool shape that I'm doing here, right? That's why geometry is so fun. Look at all the patterns. Okay, now I'm going to label this as B double prime, because it's kind of the second rotation here. And again, it's at negative 3, negative 4, right? Starting here, left 1, 2, 3, and then down 4. So that's exactly where it needs to be. Okay, now you can hopefully kind of see where this is going. As I do my 270-degree, it's going to end up in quadrant 4. And the rule here is that I'm going to flip them again, and then I'm going to make it positive, negative, which happens to match to the sign indicators there. So I'm going to put my point at 4, negative 3. So 1, 2, 3, 4, and then down 1, 2, 3. And we're going to double check that this lines up, that B becomes B, I guess, triple prime at this point. So we go 90 right there, 180. You guys see that? Yep. And then let's see if I can move my hand here, line it up. Oh, look at that. It goes directly on that red spot right there. So this will be triple prime because it's the third one. And it's at 4, negative 3. Oh, actually, sorry, I should have traced it. My bad. Okay, I should still have enough on here that it continues to make ghost images. Spooky. There you go. Cool. Yeah, that's kind of how it works. You just flip-flop the points if it's a 90 or 270. Change the sign of each point to the destination quadrant, and then you're good to go. Okay, so that's our B prime, triple prime, And again, we flip-flop them and then make the second one negative. And we were golden. There you go, we got like a little pinwheel shape. Yeah, cool. All right, now real quick, this will finish off real quick. I think I'm going to skip one of these, but so what we're going to do is we're going to translate polygon A so that P becomes Q. So if I go left from P, that's 2, so I'll do the same thing here to kind of like make these shapes the same. I go down here, 3 down, 2 across here, and then I'm going to go 1, 2, 3, 4 up, and then 1 left, 1 up. Now, I'm going to measure each side here. I'm just going to count them. So that's 4, that's 2, that's 3, that's 1, and that's 2. And I can see that each side matches up here, and they're the same length, right? This is 4, this is 4. We would call these corresponding sides, right? Pair of matching sides that are in the same spot in 2 different shapes. So 4 here versus 4 here, right? 2, 3, 1, and 2, and they all match up, right? So it's kind of just a way to understand that these are the same shape and the same size. We call that congruent shapes, and this proves that it's a rigid transformation. I guess not proves fully. Once we get the angles in here, then we can prove fully that it is congruent, or that they are congruent to each other. We're going to reflect this pentagon across line L. So line L, that's our line of reflection. I'm not going to use patty paper for this. I'm just going to count, right? So this point right here is 1 away, so it's going to match right there. This point is 3 away, so I'm going to go 1, 2, 3 on the opposite side. We'll draw shapes as I go, or draw the lines as I go. This one is, let's see, 1, 2, 3, 4.5 away. So 1, 2, 3, 4.5. So this side matches to that side. And this one is 3.5 away. So then 3.5 on the other side. 1, 2, 3.5. Just like that. And then this is 1 away, and so that will complete the shape. Now again, we could see that this is 3, matches to that 3. This is 2, matches to that 2. This is basically goes from this point to halfway across here. If we knew the Pythagorean theorem at this point, we could figure out the actual distance of this, but we are not working with a squared plus b squared equals c squared yet, so we're not going to worry about that. But we can see that this 90-degree angle is going to match to that. This is an obtuse angle. It's going to match to that 150. This is a 90. It's matching to that. This is another obtuse angle at 120, and that's our final 90. You can see that this 120 corresponds to this 120, this 150 to that 150. And, that's just corresponding angles. It's just pairs of matching angles. And you can talk about corresponding vertices as well. I actually talk about that a lot in class. Like if I look at this vertice or corner of the shape, it's going to match to that corner of the shape over there. Or, this vertice would match to that vertice, that point or corner, right? I'm just going to skip the rotation because it's kind of the same thing. We can see that we have the same sizes, the same angles, and that leads us to being able to determine whether things are congruent, the same size, the same shape. So we look at this one, we can see that we have a translation here because I don't have any reflection or rotation. Okay, we're moving 1, 2, 3, 4, and then down 1. I know this is the original or the pre-image because it does not have the prime notation. So this is the image or the new shape. So we're moving right 4 and down 1. You could get through that comma. You could also write this as x plus 4, y minus 1. Is this a rigid transformation? Basically, it's asking if they have corresponding sides that are the same length, corresponding angles that are the same measure. I can see that this is 3 here, this is 3 here, and this one goes, kind of 1 over and 2 down from f prime to g prime, which is the same here. And then, y prime to g prime is 1 up and 1 over, and y to g is 1 up and 1 over, right? And we can kind of, assume that the angles are correct. Shoot, this might be kind of hard with the protractor here, but like, if I want to measure this one here, I can see that it's roughly 30, this angle right here. And if I look at my f prime, I can see that it is roughly 30 as well. Let me do that again, because I don't know if that was on there, right? This goes out to roughly 30, so this is 30, and we compare it here, and we can see we have the same measurement on these angles right here. So this is a rigid transformation. We would say, yes, it is. How do you know? I know because each shape or each figure has corresponding sides and angles that are the same measurement. And there you go, sides and angles that are the same measurement. Is this on? Yeah, good. Shorthand way of saying this would be to say that they are the same shape and the same size. Therefore, they are congruent. Again, congruent means that shapes are the same shape and same size. So there you go, guys.